Spur measurements can be one of the most time-consuming things you can do with a traditional swept analyzer because the wide span, narrow resolution bandwidth requirements for such tests lead to very long sweep times. The unique architecture of the Tektronix real-time spectrum analyzer largely alleviates this. Let's take a look at a few examples. We're looking at a 1 GHz frequency span centered at 2.44 GHz. Right now the resolution bandwidth is set to 1 MHz. We drop this down to 100 kHz. We see the noise floor drop by 10 dB as we expect, but no real change in sweep speed. Let's drop the resolution bandwidth down now to 10 kHz. At this setting, a traditional swept analyzer would typically have a sweep speed of about 30 seconds, where the real-time spectrum analyzer is resulting in about a 1-second sweep, a nice improvement of about 30x. Let's knock the resolution bandwidth down now to 1 kHz. At this set of settings, a traditional swept analyzer will often have a sweep speed exceeding 20 minutes, and we can see that this analyzer is giving us a sweep speed of about 3 seconds. That is a significant time savings in making these types of measurements. Oftentimes when you're doing spur measurements, you're interested in spurs in particular frequency regions around your carrier, and there may be other frequency regions that you don't care about. The real-time spectrum analyzer features a multi-range spurious measurement utility that makes this type of measurement very easy. So we're only going to sweep through the frequency ranges that we care about and not sweep through the ranges we don't care about. You can have up to 20 of these separate ranges to sweep through, and each one of the frequency ranges can have its own resolution bandwidth, its own detector type, its own spur threshold, and its own absolute or relative pass-fail threshold criteria for the spurs. This can save a tremendous amount of time. We're looking at a total span here from 1 GHz to 10 GHz, broken up into several different regions. The various shaded areas on the screen are showing you the absolute or relative pass-fail thresholds that were set up for each range, and they can differ by range. So we can take advantage of the very fast, wide span, narrow resolution bandwidth sweep speeds and take advantage of the fact that we can skip over unnecessary regions in the sweep and get very, very fast results for spur testing.